Hello. Hello, everyone out there around the world. Welcome to today's webinar on the design module at Advantis. My name is Philip Gehring for all the ones that don't know me. And as a heads up, with roughly 500 people on the call, we might not be able to answer all the questions you might have. Just kidding. We are a handful of folks, so we should have plenty of time in the next 90 minutes to answer all of your questions. Keep in mind, this is controls, so this is the expert of the experts. So we understand that that we are a pretty limited group of people interested in this topic. So with that said, let me share my screen here. We'll do a little bit of theory on PowerPoint, which you should see now. And then, of course, we will spend a good amount of time in the software itself. So, what do we have today? First of all, very important, we will record this session. It will be available later on YouTube to revisit. And I show some of the slides just for that people can go back to. Not spending too much time on it, especially on the introduction side. So we will start, for the ones that don't know Advantis, the company and the team, briefly talk about us. And then look at the analysis phase, just to give the overall picture, again, for folks that are not in depth familiar with the offering of Advantis. And we're also excited to be able to show you this new feature called Linked Case. We'll do a demo on that linked case, and then we'll follow up with Q&A. As far as Q&A goes, there's two ways that you can ask questions. You can ask anytime in the chat. Stefan will monitor the chat and then let me know those questions. Or in the chat, you can raise your hand and I can get you on stage, and then you can verbally ask your questions and we'll have a dialogue. Again, we are not too many folks here. I think we're like a dozen or a little over a dozen. So we should have plenty of time to answer your questions. Going on the agenda, we will then look at the design phase, what it has to offer today, followed by a software demo and potential questions. And then we'll show you also the plans for the future, what we have in mind also for the third phase, validation. So with that said, let's jump into the first item, Advantis, the company. Many of you already know that we are in the heart of Switzerland, located and been established 5 years ago in 2017 officially. We got about we have 9 individuals working for Advantis, not all of them full time. We have a lot of the development team in Vietnam, outsourced, and some individuals are here in Switzerland. Our customer base is ride manufacturers and parks around the world. And we have a clear vision, simply, we just want to be the best. And we want to be the best in class for the risk assessment software. That's what we started with, and that's what we all every day strive for. The team, again, I'm just going to briefly mention the core team, which is myself with Stefan, who founded the company, and then Vung, our chief technical officer in Vietnam, leading the team of developers. Myself, again, you can then read this if it's of all interest, been in the industry for 26 years, acting as the CEO here at Advantis. My background is controls. been doing control system design work all this time in various positions. And I'm a member of several committees, whether it's standardization committees and then also IAPA, the safety committee. Stefan acts as our COO. So he's gonna, where I bring the business requirement to the table, he's gonna make sure he breaks it down for the development team. His background is clearly software development here in Switzerland, and he still part-time works for a software development company here in Switzerland. And then Vung, last but not least, he's our genius in Vietnam, implementing all these crazy ideas that we have, again, working with others and providing this top-notch solution out of Vietnam. His background is software development. He has worked in Switzerland before, so he knows how the Swiss work, which is great. We've been very successful with little overhead doing this type of development in the past, as I said, past 5 years. So that much on us. Kind of to warm up the big picture, how we break down the development process is, considering the V model in software development, is with the 3 phases: analysis, design, and validation. Hence the name ADV, Advantis. So looking at the analysis phase, this is the phase what we consider is kind of the blue sky phase, where your conceptual design will take place, where you write your theory of operation. And then as far as risk assessment goes, this is where you at least start the risk assessment and take it as far as possible before starting your design. When we talk controls, this is where you would also word out your safety requirement specification. Whatever is in bold on the slide is within the scope of Advantis. This is what we cover within Advantis. When we look at the design phase, this is where you do your detailed design, whether it's mechanical drawing calculations, whether it's electrical schematics. This is all what we consider the actual design. When it comes to design verification, there is basically 2 elements. One is the FMEA for mechanical and structural, where you look at an existing design and then you do an what if analysis. So FMEA is one verification method. When it comes to control system design, it's the seal or performance level verification. The term Systema, that software, is probably well familiar for many of you on this call. So that's what we call design verification when it comes to controls. So there are both in bold. We have future plans to do an FMEA module to integrate that into Advantis. And we do currently have, and that's what we're going to talk about, this control system design verification, which I'm going to obviously show in greater detail later. The third phase is what we call the validation. In validation, you can, what most people know, validate by testing, which is these acceptance tests that you would do at the end of the project, whether it's a factory acceptance test plan or a site acceptance test plan. But there is also more than just testing. There's also validation by analysis. And that just happens on the documentation side, where you potentially have a third-party inspector reviewing your documents, creating a validation report. Because believe me, if you don't do this kind of validation by analysis, you will miss certain things by testing, especially when it comes to safety function. A safety function performs real well, whether it's implemented on the standard side of the code or on the safety side. And I've seen that myself, that you only detect by analysis. But people, when they think validation, they think testing. We will be able to cover both in the future. That's why they're both in bold letter. Again, that's just as a warm-up, the big picture. So looking at the overall risk assessment process, this is work that we're currently doing at FMEA, at the ASTM F24. I think Andreas is on the call. He's one of the core team members, and we are now excited to have the first draft out for ballot. Depending on how many negative votes we will receive, we eventually gonna have a first initial released draft, potentially standard next year. We'll see how smooth that resolving of the negative votes will go. But so far, and that's firsthand information, it looks promising. At the end of this week, the ballot cycle closes. So we only have a handful right now of negatives. So we'll see how many more will turn in. And as the ASTM rule goes, they have all to be resolved before to be able to publish the standard. So any negative can block the publishing of a standard. That's just the rule, the procedure. And so what you see here is the step-by-step process that we've defined, and coincidentally, Advantis follows this process pretty well on. So, for example, the hazard identification piece is just shown here. I'll walk you through a case afterwards, real quick, what these elements are. Next step, risk estimation, risk evaluation. Same thing, we do that at the beginning when you first do an initial estimation with a risk matrix, and then you potentially have an intolerable risk, you do some risk reduction, and then you have a follow-up risk estimation. And then all this goes into what we call here the results, is in Advantis the risk assessment report. So now let's talk about the new feature that we've added. It's called linked case. Basically what that is, we have a risk reduction requirement established by one company, but that one company will say, I cannot do the solution for this requirement because it is not in my scope. So the solution for this risk reduction measure will be provided by another company, which means that other company needs to know about this requirement. So there needs to be some sort of communication between the two. This is what we call a linked case. I'll show you in the software in greater detail how that process works. That's something we've worked on in the past months and has been released a couple months ago. So there are two use cases for this. Number one is you have a designer manufacturer and an owner operator. So normal scenario, right? Manufacturer provides a ride to a park. So this works if both companies are using Advantis and they both have established a project in their database for that particular, let's just say, roller coaster. What they first need to do, the two companies create a project connection between them inside Advantis. So then we know, okay, those two are connected with each other. How this works is the designer manufacturer places a request for connection. The owner operator has to accept that connection, and then that connection is established. At that point, the designer manufacturer can, in any of the cases, establish the risk reduction requirement on a case and then say, look, the solution is out of my scope. I don't provide the fence. So you, Mr. Customer, have to deal with that. So he selects the connection, the other side of the connection, and then that automatically gets transferred to the owner operator. So now, provided by others, select the project. So the owner operator receives the linked case in its case list and has now the possibility to enter the information, which is then automatically updated on the designer manufacturer side. So what is important, it's not that we're transferring the entire case over from the designer to the owner operator. The case still resides with the designer manufacturer, because there might be other risk reduction measure that the designer manufacturer is taking care of. We're only kind of linking that case over to the owner operator. He's going to take care of that solution. And so it is going to be reflected in both of the reports. But it's still, the ownership is with the designer manufacturer. An other use case is the designer manufacturer does not outsources the controls. So let's say he has a dedicated controls company who's doing that. So same setup, both companies needs to have a project in Advantis. There's a connection established. So we have done that. So the control system supplier, CS, accepts a connection. And in this case, we have a risk reduction measure of type controls. Now, this is going to be something we would like to get some feedback. The designer manufacturer has to fill out the risk graph and the safety requirement specification. And only then he's going to select the provided by others, selects the project, and then the control system provider can then enter the solution information for this particular linked case. We have had some debate if we should let also the control system provider do the risk graph and SRS. I'll show you this again when we do the demo, then maybe it's clear what I mean by this. So I already see the chat is going, Stefan. Let's see here. No questions so far. All good. Okay. So with that said, let's go to the demo. Change the screen real quick. Okay. So what you see here, I've got the browser open. I've got two tabs. I have company A, webinar A on the first tab, which is my other company, Gearing Engineering. And then we have, sorry, I'll click here. And then we have webinar B, and that's Advantis Academy. That's the B company. So A, let's say, is the designer manufacturer. B is the owner operator. So for the ones that are not in depth familiar with the analysis phase of Advantis, I'm just going to go through one case, very straightforward. So let's look at 1110. So here we just got, and let me put the, if I find it, spotlight, because you don't need to see me. Okay. Okay. Collapse all, big picture. First part, in any case, is a hazard identification. We have an initial risk estimation, evaluation. That's always part of a case. Then followed by one or however many risk reduction measures that you will have to add until you get to a tolerable risk. The hazard identification piece has basically three elements: task, hazard, hazardous event. The task is how a human being is interacting with the machine. This is all part of the base module, and I'm not going to go into too much detail. This is all established here. These cases, the area, the hazards, all this information is kind of the prerequisite, as we call them, and ASTM, that needs to be filled out first based on the theory of operation. That tells you, for example, participant is walking entrance queue line upwards. That's a task. That is what's going on. If we go back into the case, this particular one, This is actually very generic. This is about the structural integrity. So here the task is just a passenger riding inside the PCU, the passenger carrier unit, during regular operation. So next part is the hazard. So something goes wrong. And these hazards can be created by the user, but we also have a preloaded list of hazards based on the EN standard. So in this case, incorrect design calculations lead to the loss of strength, structural mechanical failure, and then consequently, people are falling, crushed, impact, pinching. So these two elements are then summarized in this hazardous event. So in this case, we say loss of structural integrity causes permanent damage to track structure, which possibly leads to PCU derailment. So this is a roller coaster, a derailing PCU, derailing train is obviously a bad day. So with this information, we go into the next step where we do an initial risk estimation with the two parameters, severity of consequence and probability of occurrence. These parameters can be defined in a risk matrix that is fully customizable, not fully, but to a certain extent, as far as how many levels, what the description is, and so on. So you select your level here, same with the probability. Here is a picture of how this particular matrix looks like. This is a 5x5. Normally we work with a 4x5, but again, this is totally customizable to your company request or to your company standards, or even to a request by your customer. Let's say Disney, Universal says, look, if you work with us, you need to use such and such matrix. So you can change those project by project. What is unique to Advantis is that we ask you to do a comment, justification why you picked this parameter. Here it's fairly obvious, but in certain other cases, it makes sense to kind of justify, even for yourself or the team, to remember why did we pick severe or major. So we have an intolerable risk level. We know that we need to do something. Something that we've added, even for the ones that have used Advantis in the past, is attachment. You can add now attachments. We have upload space where you can add pictures, documents, and such that for your record, either whether it's for your own that you can look at it here, you can then view whether it's a drawing or something, and then it can also be cross-referenced in, or it will be cross-referenced in the report. So that's one new feature that we did not cover in our last webinar. So then, okay, we're intolerable. We know we need to do something. Risk reduction measure, there's 3 different types, such as design, controls, and operations. So design, here we say all static and dynamic calculations shall be carried out by qualified personnel. So it's a requirement, hence the word shall. Here we add a second one, that it has to not only have theoretical knowledge, but also practical experience. So that is a requirement that we can word out early on in the design process, and later on, we follow up with the solution. In this case, it's the human resource department who has to provide the staff listing that shows for every individuals involved in these calculations that they are qualified by the proof of their educational background and how many projects they have been involved in and such. This is very important for managers. That is basically covering their behind to make sure they do everything correct on their level. Not too many managers have realized that. But especially when we talk functional safety management, this is critical. IEC standard clearly asked for that. I've dealt just recently with a project in Australia, and trust me, whether the manufacturer and the control system provider, they were grilled by the authority because they didn't have their act together when it comes to these kind of things. So I think more and more we'll see this to stiffen up a bit. So just going back to the actual case and the example. So then we follow up with the risk estimation. In this case, we say, look, if the event happens, it's still catastrophic. So there's no change from the initial assessment. But we're saying from the original high, where we started, probability, we are going down to moderate, reduced probability of occurrence due to this measure. So we still need to do more. And I don't want to cover too much in detail. So next one says you need to do these calculations according to regulations. Here is a reference to the regulations. Then here's this calculation sheet. So we're down by 1, but we're still intolerable. So let's say next you need to use the right tools when doing this calculation. Here's then a proof of what tools you are using for this. So we're down 1, we're undesirable, we're still not green, so we're going to do more. Last but not least, we're also hiring a third party, so it shall be verified by an independent organization. In this case, we're hiring TUV, and this is the report that they're providing. Again, always requirement solution, and only if the solution pleases the requirement, we go 1 tick down. And so now we're improbable, although it is a catastrophic severity. So now we're tolerable. In this case, we're also adding 1 more, which is operational, that we ask in the right manual for periodic inspection by maintenance staff. So in case there would be something over the years, a crack or so, that maintenance staff would, by periodic inspection, and this could also say like weekly or monthly. The more specific, precise this requirement is, the better. Here we follow up with the maintenance manual, specifically chapter 343. So like I know this, we call this a closed loop risk assessment. This loop is closed. I know it is documented. So now we're good. So this is in a few words how a case works. Again, the ones that have worked with Advantis know this. So let's move on to a case that we can, that this company says, you know what, that's not in my scope. I think I picked 6002. So here we have a participant who's walking down the exit ramp during regular operation. He loses the stability. He's falling from the surface he's walking on. Falling, crushing is the consequence. So we're picturing this event that a participant, let's say, is falling from exit ramp at height, maybe it's a little better, of 3 meters. The more specific you are here, I need to know that it's 3 meters, because if it's 12, I might not pick severe. I might pick catastrophic. With 3, the team can argue, yeah, you know what, 3 meters. Yeah, if we're conservative, it is fatal. Maybe it's this. So, but that's why this type of information is important. Okay, so we say reversible injuries expected, severe. Here we add some numbers, justification for the moderate. We say PPH is 1200. We have a 6% grade. Slippery surface, so the chances is, in this case, moderate, which means will occur several times again during the life of the attraction. The hazard can be expected to occur often. I clearly need to do something. So here, then we say, look, exit ramp shall be designed to avoid a fall from the ramp. That's what the designer manufacturer can say. But he's saying, you know what? I'm not providing the exit ramp. That's part of the building, the station building. That's not on us. So they say, no solution from my side, provided by others. So now select a connected project. I did a little bit of preparation work, believe it or not. I connected, let's say first, I connected this project here, webinar A, with webinar B of Advantis. The way this works, it works via email. You know the person on the other side who's responsible. You send him an email, he's going to accept the request, and then you're connected. It's pretty straightforward, but that's the mechanism behind it. And then you can also define whether they can see whether company B, like Advantis, can see my other solutions or not. You can determine that. So we have that established. So by having that connection, I can now select this. Okay, so now it's connected to Advantis Academy, project webinar B, and it tells me they have not provided a solution yet. Okay, understand. So if I go to B, and hold on, I do this wrong all the time. You need to save it, or you think you get nervous and you think your developer has forgot something. But if you save it and then you go here and you do actually a refresh here, ta-da, you have a linked case. Now I'm in the other company, Webinar B. I have a linked case from Gehring Engineering, HE6002. That's their project name. So I open this. So I cannot change any of their data. So somebody over there decided all this. The only thing I can do is say, this is my solution. Very creative. Boom. So update it here. I go back here and I update. Here we go. That's just the web-based stuff. You need to do that. Look at that. This is my solution. So I cannot change it, obviously. This is owned by company B, and it tells me this here when it was updated by whom. Okay. So the rest is just straightforward. When I say straightforward, it is always meant that if this requirement is met by this solution, then these follow-up parameters are true. So this should not depend on the solution. The verification or validation that this solution meets the requirement, this is something a third-party inspector would do. That's important to understand. So now we have this tolerable. Let's save it. So I should be able, actually, I haven't done that. I create a report. There's a few incomplete cases. Here I can then decide whether I want to print the linked cases. Just going to do a draft. So we're printing these reports fairly quick. Independent how big they are, we pretty fast. And if this works, I should be able to go to 6002 falling follow-up. And then we see measure 1, the solution. This is my solution provided by Advantis Academy, and that's the project. Okay. So this is where we think we're adding a lot of value by fully integrating these two companies working together by sharing this kind of information. But, you know, this is our idea, and the reality will tell us if this is how it works. I mean, if this is accepted or not. Before I forget, and before we take any questions, I want to make sure I mention the help menu. We have pretty comprehensive user manual here, one for analysis and one for design. So the one for analysis is 200 pages. It's interactive. You can just click here, look at certain things, go back. I mean, interactive, it's not a dumb PDF, it's a smarter PDF. So this should answer a lot of the questions you might have. And we'll have the same on the design. Also, what we've added is feedback, possibility for feedback. If you don't like something, you can let us know. That gets straight to us, and also development. You can tell us how important it is. And when you do this, of course, you get our attention. We'll look at it, and we'll at least put it in our task list. Can't promise you how fast we respond to it, but we'll certainly put in our task list. So one more thing before we stop. Let's go to company A. I want to show one more case, and that's the one that has controls, because that's what we're going to be using in the design. So here we have vehicle-vehicle collision. Let's look at this guy here. So here we have people inside a PCU at load unload, and we have equipment malfunction. We have an unintended start of a passenger carrier unit, so it results in a collision with impact, crushing, excessive G-forces. So the event is passenger injury due to rear end collision at 2 meters per second of stationary PCU at block 02. So from 1 to 2, bang, 2 meters per second is the worst case, or is the nominal speed. Again, very important. If this number is 8, this parameter might change. But the 2 meters per second, the team here said, you know what? Collision at 2 meters per second caused a reversible injury to multiple people. Probability, that's an assumption. We just say low. Malfunction of non-safety related equipment has a probability of low, which means likely to occur several times in the system lifecycle. That's what I conservatively have to assume, that either the PLC drives nuts or a standard drive goes banana and just starts up without any reason. So we know we need to do something. In this case, we pick risk reduction measure of type controls. When you select controls, you have 2 more items here to work on. So first, the requirement, we say we need a safety-related control function, SRCF, shall keep block 01 friction wheel drivetrain in safe torque off condition as long as block 02 is in occupied state. So that's a logical interlock block system. Very straightforward. STO means safe torque off, so no power going to the motor. So now, and that's given by the standard, whether it's the risk graph or a risk matrix, if you choose to go with the IEC, you can select at the beginning of the project which route you want to go, whether it's ISO 13849 or IEC 62061. 90% of the customers pick this guy here. So then we have this loaded, looks like this. So you got the 3 parameters for the ones doing control system design. They know those, S, F, and P. That's interactive, whatever you select. If I select F1, so then F1 is highlighted and I get a performance level D. We do give some guidance here on our recommendation on when to choose F1 versus F2. Same here. What is S1, S2 here is obviously matched whatever you have up top for the your severity parameter. And then the possibility of avoidance normally with these kind of machines is P2 because how fast they move. Usually the guests cannot do anything anyway. Maybe the operator, but to assume that an operator reacts to an issue is in time is very slim. So we say you can only claim P1 if it's an enabling action, such as like a start enable after checking the restraints where there is no time pressure. So that's to be selected and justified. It's optional if you take the more severe one. If you claim F1, we want a justification. So then performance level E. Next step, safety requirement specification. That needs to be created for every single risk reduction measure of type controls. So here we say a function, we have to define, aside from ID and title, the functional requirement. What is the safety function functionally to do? And in this case, it's fairly straightforward, copying what the requirement asks us to do. So here it says block 1 friction wheel drivetrain shall remain in STO if block 2 in occupied state. Again, pretty straightforward, a so-called logical interlock. It is applicable in auto mode. I'm not going to go into too much detail. It depends which mode it is valuable based on some input information you give up front. If you have other operating modes that apply to regular operation where this particular hazardous event is taken care of, then you might have different operating modes where this particular safety function needs to be active. So this is something Advantis does automatically for you. Important is, sorry, forgot, the integrity is PLE, linked from the risk graph above. And then we have some non-mandatory items here, whether reset condition, muting, standard reference comment. Again, you can add any kind of attachment you might need, because this, the SRS, is the transition from analysis to design for the controls folks. A controls engineer with this information should be able to create the safety function, to design the safety function, whether it's from a hardware perspective and also software. All that information needs to be in this SRS. So I'm showing you an existing design where we already have a solution. So I'm going to go over now to the design side and show you that solution. But before we go there, I want to go back and answer some questions if we have them. Sorry. Stop sharing. Stefan, how are we doing? We're doing good. We don't have any questions. Anybody? Anybody still here? So Mr. Hippie is pleased. There's no questions. Okay, that's good. Interesting. You either all fall asleep or overwhelmed, or I don't know. Good. Okay. Awake, no question. Thank you, sir. Appreciate it. Good. You know what? I need a drink. So next, we're going to look at the design. That's what we're here for. Okay, so design verification. The output of this, similar to the risk assessment report on the analysis side, is what we call a design verification report. This report should prove that the actual design meets the requirements defined in the analysis phase, what we just learned in the SRS. So the input into this ordeal is the SRS. There are two parts to it. There's a hardware design and there's a software design. The hardware design is the design, the device evaluation. So what components, devices am I using that meet those requirements? For example, if I have a PLE safety function, I know, what type of devices I need to pick. Connection diagram, how are they connected? What is the architecture behind it? Those are the two core elements in the hardware design. Software design, similar. I need a block diagram. Well, this is kind of unique. I just always believe that if you don't have a block diagram showing which part of the safety function is implemented, a third party has almost no chance to validate your safety function. So having a block diagram that kind of separates out where different elements are in the code by providing a cross-reference to the PLC code is, in my opinion, the only way how somebody can validate the code. Because only you as a software developer know, where is which piece. And so I'm going to show you an actual example, this one here, the block system, how this has been done. It's not rocket science. It's just a matter of documentation. So with that said, let's go back to the software. EPIA. Okay, so now we go from up here, A to D. So D here, SRS is our input information. We have two SRS that need addressing. The first one, block system, the one that we just looked at, and then I create another one, overspeed protection. So SRS 1131. So safety function design, this is similar to the cases where you now design your safety functions. So you create a new one here, or let's just look at an existing one, which is a little bit faster. So for this particular SRS 1131 that we just looked at, block 1 to block 2, the logical interlock, that's our going in information. If I collapse this, so you now get the big picture. You see it also on the right-hand side here, what all is involved just for that one safety function. So first step is the SRS. Next is a top-level block diagram. Then we have hardware. On the hardware side, we have it split into input subsystem, logic solver subsystem, and output subsystem. You have to have at least one of each category. That is the definition of a safety function. A safety function needs input information, a logic solver, and output information. I've seen many documentation where the safety function only had portions of it, and I disagree. I think you need to, whether it comes from a different party, through network, whatever, but there is somewhere some kind of input information is needed for the logic solver to make decision to solve the logic, to make a decision on, in order to turn an output on. That's just my personal opinion. So we want you to have at least one subsystem of each category. Then comes the schema verification. We're going to look at all these in greater detail, and then the software risk reduction. So we've looked at the SRS, so we know what to do. Top level block diagram. The intention is that you see this on one chart, you see all the different hardware components involved. So this is up to you how you define these individual subsystems. So right now here we have, the easy one is always this guy here, the logic solver. So here we have LS, safety PLC. On the input side, because we say it's only active in automatic, let me hide this spotlight off. Boom. Because we use it in automatic only, eventually bypassing certain things in other modes, the operating mode is important. So we need to consider the hardware for the operating mode. We need to know the block status information for block P1, and we need to know the one for P2. And then on the output side, we have the drivetrain of P1. So those are the subsystems. So now let's look at them one by one. So this is the first one, operating mode. I have to determine what type of category that I have. You know, B, 1, 2, 3, 4. So you pick your category you claim for. You optionally write a purpose of what this is for. Big picture. So in this case, very straightforward. Provide operating mode information for the logic solver based on the operator OPM, operator console key switch position. So we have a key switch. You can, name this whatever you want. We have a cross-reference. If I go to edit, you see it a little better. So I give an identifier, what type of device it is, and I can add new ones, whatever you like. So key switch in this case, what it does, this one is the mode selected. I do then a second channel where I see this, say this is the mode not selected. So those are my two inputs. One is always active, the other one is always not active. If I only have two, in many cases we have more. Very important in order to be traceable, the cross-reference into the schematics here. And then come the nice thing is supplier reference. So here we're using a PILS, and here we see the data. So it's a PILS device with some already preloaded PFH numbers. So this is what we think is cool, because we import all that information into the database automatically for you. So this is called the VDMA interface that Systema uses to get the information from all these different manufacturers, whoever, PILS, Siemens, Rockwell. I'm gonna go out of this real quick. I'll show you this here. So here is this list, and you can filter by input logic solver output. You can filter by the manufacturer. So those are all the ones that provide their information in the VDMA, which is a standardized API interface. Unfortunately, not all of them do. That's a little bit of a downside right now. They're still adding and adding more to the VDMA. We check it monthly. We scan, and whoever provided more information, we add it to the database. So you don't have to do anything on this side. And if certain devices are not in the database, you can add it yourself. You can create a new device and enter the information. This is obviously our first step in order to copy what Systema does. We are not there yet, but we are definitely working towards that in big steps, that you do not need Systema anymore, that we do the same thing. Because keep in mind, Systema does just what the ISO 13849 is telling you to do. Instead of doing your old calc, Systema is doing the calculations. This is not rocket science. We should be able to do that, but doing it is one thing. Being certified that this is actually correct is another thing. And that's the part we don't have control over when we go to a TÜV organization or somebody else to get this part certified. This is obviously something we need to do in order to for people to believe in us, although Systema doesn't offer that certification, but we will. So we want to do the same as Systema, but we want to do a better job, and that's something you need to tell us if we do or not. But we want to keep it as simple as possible. As you know, the ones using Systema, there is subsystem, there is blocks, there are channels, there are devices, elements. So we want to keep it as clean as possible. All we have is devices and then subsystem. In the future, we will allow nesting, one subsystem and another, but right now it's devices and subsystem. So within a subsystem, we have here the three devices, as I mentioned before, the key switch mode selected, the key switch mode not selected. So those are wired to a third device, and that's the safety input module. In this case, it's a Rockwell Guard IO. So here I determine the connection. I say, okay, from S1 origin, destination S3 is my functional channel 1 hardwired. And then S2 to S3, functional channel 2 hardwired. And then from S3 to the CPU, logic solver, both functional channel 1 and 2 network. It's very straightforward. If I go to edit, connections, it's very straightforward. And whatever you do, it's reflected in the drawing. You don't need to do any drawing. The drawing is automatically updated based on your selection. So you have either hardware or network, and that's it. So also then important functional description. So the purpose is optional. Functional description is mandatory, that we know what is the function of this particular subsystem. Okay, so that's for operating mode. Then we have block status P1. Pretty straightforward to detect the block status. So we have a proc switch, one proc switch, second proc switch, but also wire to safety module. Boom. Then you can also obviously copy these subsystems. So we have another one for P2, identical, and you can create as many subsystems as you want. Then we got the logic solver, just one device. In this case, it's GuardLogix. Again, all the numbers are included, all in here, all done, nothing to add. Then last one, the output. In this case, we're using a drive. For the friction wheels, it's an SEW Eurodrive that is connected through the network. In this case, we're using the MobiSafe card, certified card that achieves PLE CO3. Okay, so again, functional description. Okay, so that when you do all this, automatically it does update this top chart here. Again, you don't need to do any charting here. It's all done by Advantis. So right now, as we are still working towards Systema integration, we just provide you, or you provide the cross-reference into the file. So we would just like you to enter the information there, get the PL that it spits out, say the project name, which SRS it is, the PLE that Systema gave you, and any potential replacements. Those are the replacements you need to, that will be listed in Systema that you would have to enter here. Those are all the devices that need to be replaced prior to the 20-year mission time. Systema assumes, and the standard requires you to assume a 20-year mission time. If anything has a shorter time, you need to list those components here, and that information needs to go into the maintenance manual, so people, your customer knows when to replace a push button, for example, because it's just been pressed too many times, and these numbers, it will not meet the requirements anymore. Okay, so that's all on the hardware side. Software is pretty straightforward. We start with a safety function block diagram. This is not automatically created in a sense that you can move these blocks around however you want. But basically you create a block, and that's totally up to you how you have your code organized. Because I'm a strong believer you should not necessarily organize your code by safety function. I know some customers, some parts ask for that. I think that's just not right. You should have other criteria of how you structure your PLC code. And then that gives you, with this concept, gives you the flexibility that you create the code that best works for you. But here you document how you work. So In this case, we did create a block A for the block status of P1. So this corresponds with the hardware. We have a block B for P2, and we have a block C for operating mode, but it doesn't necessarily have to correspond. And then here we have a block D for our advance command. And then this drives block E here, which is drive control. And there's probably other commands that also are going to drive control. So this is linked to the output module. So there are certain blocks here that are, and you can also call them module or whatever you want, that are linked to hardware. And then this is more of a functional code. But that's just my personal way of coding. It doesn't matter. You're totally flexible with the advantage of how you do that. Important is that you, for every block that you create, that you give a cross-reference, well, purpose, if you choose to. I was lazy. There is no purpose here, but there's a functional description. So in this case, if proc switch 1 and 2 is flagged, then 1 or 2 is flagged, then the block is being occupied. So what's important is the cross-reference into the program. What is the program name, what is the routine name or designator, and which rung. In this case, it applies to all the rungs. Disclaimer, we do, or apologize, we do strongly, for the ones that program guard logics know, this is, Rockwell environment. And we have plans to open it up or to even make it selectable, that you say, okay, I have a Siemens PLC, and then it automatically takes, function block and lets you use different terms instead of program, routine, rung, or we just make it customizable that you just select whatever term you want to use. But you get the intention. The idea is you hand the program to someone and you give this design verification report to someone and they can find their way. And I believe without something like this, you just simply don't find your way. One element is you have to determine whether something is in standard or in safety. If it's standard, it's gray. So, sometimes certain information is mapped over from standard to safety. And that's, again, up to the reviewer then to decide, well, okay, but in this safety function, we are, doing certain action on the safety side based on non-safety information. I disagree. This is not meeting the PLE requirement. Okay. Again, I've seen many programs where, they looked more like this. So, everything was coded in standard, and the result at the very end, boom, mapped over driver safety output. Super, trooper. You can do all sorts of testing. It works pretty darn well. You will not find this unless you do an analysis. So if you have this design verification report, then the inspector can look at it, or the reviewer, and say, okay, first of all, it meets the requirements of the SRS. And second of all, when I look at the code matches what is in the report. We do realize it's still a good amount of editorial paperwork, and we will try to automate as much as possible going forward. But this is where we're at right now. I'll leave it where it is. Save it. Yeah. Okay, let's check my notes. Where are we timing wise? We are still okay. Got 25 minutes left. Trying to figure out. I hope this gave you a good impression. Let me stop sharing. See if we have any questions. We do. So let's move over. Okay, we have one. Andreas, can you define something like the mode key switch as a subsystem to multiple safety functions? Interesting question. Sort of. What I have not mentioned yet is the so-called project templates. We have right now, we can copy subsystems within a safety function. We for some reason cannot copy a safety function, a subsystem from one safety function to another. But when it comes to like the key switch, the operating mode, which is something you will always have in every attraction, you can work with project templates. And the project template is really cool, as you can preset all these things and you can create certain safety functions that have these subsystems already in it, like even like an e-stop. An e-stop is one that comes up a lot. As we all know, an e-stop is a manual e-stop. Is pressing a button per se should not come up as a safety function, because never ever should you have to rely on an operator pressing that button, as we learned before, because it's just not going to work. So the write needs to be safe without an e-stop, but still you have an e-stop and you want to document that your e-stop is good. So we have this option of doing an independent SRS. So you can create an SRS that is not linked to a case. And e-stop is a good example for that. So you create that e-stop SRS that then needs to be documented by the control folks, and that can be, for example, in this project template. But we will continue to work on these things, like even be able to push something into a template, because the template, as it works right now, this applies when you start a new project. And so this is like a one-time snapshot. You take the information from the template. You can have your own risk matrix. You can have a template, for example, for a roller coaster. You can have a template for water rides. And so you have some specifics that you can preload. Even the terms, hazards, tasks, that can all be preloaded into the template. We have right now a big project going on in the US where the park works with 4 different vendors, and the park created, for like over a month, they created this template where they inserted all the information into the template, and then once that was complete, they deployed it to these vendors, and now these vendors have to work under that template to have this consistency as far as terms and such. So that is one option. Hopefully that answers your question. But yeah, as far as copying, it's always a little bit of a scope thing, whether something is project scope, whether it's template scope, whether it's company scope. So yeah, that much for that. If anybody wants to talk, just raise your hand and I can bring you on stage, and then you can talk. You can always turn the video camera off if you're too shy. But yeah, if you want to verbally ask a question or have an exchange, that's fine. If not, we will a little bit look into the future. And this would be also good to, at some point have some feedback, especially on the validation side. So let's carry on. We got 20 minutes left. I want to be cautious of time. So future, on the design side, FMEA, as promised, because, the mechanical guys say, hey, cool stuff what you got, on the control side, it'd be cool to have something on the mechanical side. And so we are looking at 2 options, or eventually have both: an internal self-develop option, and then also create an API for existing FMEA software to be able to integrate FMEA. A lot of people, get confused with risk assessment FMEA, say, I do an FMEA, don't need a risk assessment. But then, yeah, people that know that that's really just the verification of an existing design. You need to have a design in the first place. It does not replace your risk assessment. It's a different thing. So Systema, of course, replicate what Systema does, just better. What we believe is better. You will let us know. What Systema always does better is the pricing. That's hard to beat. Free software is really hard to beat. You want to know how much it costs? Just to have it mentioned once, default pricing for a safety function is 40 Swiss francs. As of right now. Once we have Systema integrated, it's double that. That's at least the pricing price point that we're anticipating right now. So we better be good for that. And of course, we will be certified. That's also, positive over Systema. So that's planned on the design side. That's our plan. We have the team working on it already. Second item, where we also started to work on. Oh, sorry, something went wrong with my animation here. Is acceptance test plans that basically you can create your acceptance test plans. So print an ATP and execute, sign on paper, and then also a digital that you execute the ATP digitally on an iPad and then sign electronically. That's our goal. On the control side, we want to show you how we think that could look like. On the mechanical side, it's pretty straightforward, but when it comes to controls, since we have so much information already from analysis and design, this is what we have in mind. So first, we know what the requirements are from the SRS. We know what hardware components you picked for a particular safety function. We will know the failure modes of the components, and that's something we let you enter as you do the design. Let's just say a contactor. Contactor can fail on, it can fail off. Those are just the failure modes. We know which failure mode is safe versus dangerous. That is something, once it is implemented in a given safety function, that you can also flag. Is not turning on, normally a safe failure mode. Not turning off, normally is a dangerous one. So you do the coding flag as part of your design. So at that point, we have all this information already. We let you define your own desired test sequence. We know certain customers, they have like a multi 9-step test sequence. Other have, maybe you in your company have certain sequences, what you want to do. You can establish those in a database. We let you import your PLC fault list, because eventually you want to know the right fault number for any kind of test. And then we let you define the scope of the ATP in a sense that you can say, look, I want to create an ATP that only shows me the dangerous faults. I want to, just tailor the scope of your ATP, or I say, okay, I want every safety function, every device in every safety function, every failure mode tested. And then you press the famous button and you have your ATP written in a few seconds. And that's where it's really powerful. That is because we know how many hours go into just the creation of these reports. It's ridiculous. These test plans. Sorry, it's ridiculous. So we believe at this point it really scales the use of Adventus. So again, that's our plan right now, what we have in mind for implementation. I would be really happy to hear some feedback, whether that's something you think is overboard or that's really cool, and when do we have it. not this year. But we're working on it. So that's kind of the future, what we have in mind for design and validation. So, any question now? When you will do that, up to when? Sorry, Hugo. Try again. Or in German. When will we have this future plan implemented? Okay, as I said, we've started on both. As far as design, the system integration, that's at conceptual design stage, where the development team is already working on, breaking it down. On the validation, it's more on my side. I wrote down the business requirements, like what I just showed you. We might start, with a reduced scope. It all depends how much we have to do on like daily business that we get to. It's hard. I cannot promise you, especially with Systema, with the certification, that piece. We need to talk with TÜV, who's most likely going to certify, because we don't want to go to market without the certification. It would not justify the additional cost. So again, it's hard. Not before like Q2 of next year. Both. Yes, it will. Brian is asking if we have this on YouTube, and yes, it will be available as the others are on YouTube. Yeah. You're welcome. So, if there's any other follow-up question, just shoot me an email, and we can also do a more detailed presentation for you. Do you foresee that the automatic ATP generation will create perfect procedures, or do you expect that they will need to be tweaked for systems with real complexity? No, I believe that because we have this very structured approach where you start with a case, you break it down to the SRS, then comes the safety function that meets that SRS. We know exactly what components are involved in that particular safety function, and then we can validate a particular safety function top notch with that sequence, what I just said. I think right now, because a lot of these big complex projects are being approached in not such a structured modular way, that it is overwhelming, and you need to tweak, and let's test this and to test that and such. I've pushed that particular end user that is doing these kind of complex systems in a way that I say, look, here it is. These are the safety function, and we can do what I call green path, just the logical interlock testing without any fault induction, make sure it actually does what it's supposed to do. And then we do the fault induction where we fail every single component in that safety function and look at the behavior. And that's how on a current project, the test plans are written exactly that way. But it took 4 freaking months to write these test plans. And that just drives everybody banana. And that's, what we try to avoid. So I think it helps to reduce the complexity. But, will we allow for manual tweaking? Probably, yeah, then you need, but you should not have to. So. Hope that answered it. Anything else? We have 9 minutes to go. Okay. No further questions, Your Honor. That's good. So then all I have to say is thank you for staying, all of you. No, nobody left. Well, yeah, nobody left. Good. Again, you can revisit this soon. Normally, it takes a couple days or so when I receive it from the Demio, the platform that we're using here for this webinar. And then it'll be on YouTube if you want to revisit something, want to show your colleagues, and we're happy, again, to do a one-on-one. If you have further questions, we're here. So thanks a lot for all of your time, and see you on another one in the very near future. It will not be our last one. Take care.